In this video, we will discuss radicals, square roots, and cube roots. Before discussing what a radical is, we want to first remember what an exponent is. Recall that an exponent tells us how many copies of the base term need to be multiplied together. So in our example here, we see 4 with a little 3 above it. That 3 is the exponent, and 4 to the third power tells us to do 3 copies of the base term 4 multiplied together, and that would equal 64. The radical, which is a new symbol in 8th grade, is the inverse operation of an exponent. The radical is denoted by this symbol here. It looks like the division symbol with a tail on the front of it. The number inside is called the base, and the number outside on the foot is going to tell us to what root we need to find the number. In 8th grade, we will cover the second root and the third root. For the second root, you will usually see a radical without a number on that foot, and that means the same thing as a radical with a 2 on the foot. If we ever see a radical with a 3 on the foot, they're asking us to take the third root, and in high school you will work up to the 4th and 5th and 6th root as well. Now, it's important to realize what an inverse operation is if we're going to call the radical the inverse operation of the exponent. Inverses in math are the reverse operations that cancel each other out. So for example, adding and subtracting were inverses. If you took 10, added 5, and subtracted 5, you would be back in the same place. Multiplying and dividing are also inverses. If we were to take 10 and times it by 5, would be at 50. 50 divided by 5 would put us back to 10. Exponents and radicals are our third set of inverse operations. The second power and the square root, for example. If I were to square 5, do 5 times 5, I'd be at 25. And the square root of that, the second root of 25, would equal 5 because 5 is the number times by itself that makes 25. We see to the third power and the cube root would be inverse operations. If you raised 4 to the third power, 4 times 4 times 4 would give us 64. And then if you took the third root of 64, we would figure out that the answer is 4 because 4 to the third power is what makes 64. A little more focus on the square root. The square root again is the inverse operation of squaring a number. We can show the square root with a radical that has a 2 on the foot, but more likely they're not going to put any number on the foot, and that means you need to take the square root. That's the first root we can find. Another way to understand the square root is that this expression, the square root of 25, is really saying what number to the second power equals 25. So that's another way where we can understand why the square root of 25 is 5. Finally, for cube roots, we see the same thing. If we see a radical with a 3 on the foot, they're asking us to take the cube root. That's the inverse operation of cubing a number, or in other words, we want to say what number raised to the third power makes 8. In this case, the cubic root of 8 is 2 because 2, when raised to the third power, would make 8.